Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the discriminant. So by the end of the video, you should be able to calculate the discriminant for a quadratic equation and then use it to determine how many solutions there will be and also the type of solution, i.e. whether or not the solution will be rational. So any quadratic equation can be written in the form ax squared plus bx plus c equals 0. So when I talk about a, b, and c, I'm talking about the coefficients of the terms. A, the coefficient of x squared term, b, the coefficient of x, and c, the constant term. It turns out these coefficients determine the number and type of solutions. So the discriminant, which is represented by this triangle, is just b squared minus 4ac. So if the discriminant is negative, there are no solutions. If it's equal to 0, there's one solution, and greater than 0, there are two solutions. Moreover, if the discriminant is a perfect square, then the solutions are rational, so they can be written as fractions like 3 over 5 or 4 or minus 7 or whatever. And if the discriminant is not a perfect square, then they will be irrational. So there'll be numbers like square root of 2 or 3 plus the square root of 5 or whatever. So let's look at some examples now in which we calculate the discriminant. So for something like x squared plus 1 equals 0, we know there shouldn't be any solutions. The reason is I could easily subtract 1 from both sides and get an equivalent equation. Now you can never square a number to get a negative. So I know this shouldn't have any solutions. And indeed the discriminant backs us up. In this case, a, the number in front of x squared, is 1. B, now there's no x term, so that means b is 0. And c, the constant term, is 1. So the discriminant is b squared minus 4 times a times c, and that equals minus 4. So because the discriminant is negative, less than 0, there are no solutions to this equation, as we suspected. Now let's look at another example. So let's look at the example x squared plus 6x minus 3 is equal to 0. So in this case, a is again 1, b is 6, and c is negative 3. So the discriminant is b squared minus 4 times a times c, and that's equal to 48. So 48 is clearly more than 0. So there will be two solutions here. So that's very helpful because if we wanted to factorize this, we won't be able to find two numbers that multiply to negative 3 and add to 6. But the discriminant tells us that there are two solutions. So we can keep looking and we'll learn how to find those solutions later. So moreover, 48 is not a perfect square. So the solutions will be irrational. So let's now look at this example here. So a, the number in front of x squared, is 4. B, the number in front of x is negative 12. And c, the number by itself, the constant term, is 9. So here, the discriminant will be b squared. So when you're substituting a negative, you always need brackets. So it's b squared minus 4 times a times c. And if you put that on your calculator, you get 0. So that means for this one, there will be one solution. And indeed, that is the case because this turns out to be a perfect square. It turns out that this is 2x minus 3 all squared. So the only solution will be x equals 3 over 2. So the discriminant tells us how many solutions there will be and whether they'll be rational or irrational. All right, thanks so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.